not a physical thing. So why do we quit? Well, an experiment was done a couple years ago and was published in the journal Cell Press Journal, excellent journal, showing that there's a class of neurons in our brainstem, in the back of our brain, that if they shut off, we quit. Now, these neurons release epinephrine. Epinephrine is adrenaline. And anytime we are engaged in effort of any kind, we are releasing epinephrine. Anytime we're awake, really, we are releasing epinephrine into our brain. In fact, this little group of neurons in the back of our brain, it's called the locus ceruleus, if you like, is churning out epinephrine all the time. But if something stresses us out, it churns out more, and then it acts as kind of an alertness signal for the whole brain. We also, of course, have adrenaline, epinephrine released in our body, which makes our body ready for things. So think about epinephrine as a readiness signal. And when we are engaged in effort, this readiness signal is being churned into our brain. When we're relaxed and we're falling asleep, epinephrine levels are low. Okay, so they did a really interesting experiment where they had subjects engage in bouts of effort, of trying to move forward toward a goal. But they manipulated the visual environment with these stripes, kind of like fences passing on both sides of them. And by doing that, they could trick subjects into thinking that their effort was either allowing them to move forward, right, because these rungs on the fence were moving past, or that their effort was futile, that they were no longer moving forward because they would make the rungs move slowly, even though the subjects were making a lot of effort to move forward. Okay, so this is analogous or similar to being on a treadmill and you're trying to walk on this treadmill and you just can't move the conveyor, right? Or you're in virtual reality and you're putting a ton of effort, but it seems like you're moving excruciatingly slow. I had this experience recently in real life. I was doing a swim in the Pacific. I was trying to go south and I was swimming and I was caught in a current, not the kind that pulls you out to ocean. And I kept looking to my left and I saw this hotel on the shoreline. And then I was swimming and swimming and swimming and swimming. And 20 minutes later, I looked to my left and the hotel is still exactly where it was before, which meant that I wasn't moving. It felt futile. Now, eventually, either the current changed or something changed, and I eventually swam past the hotel, got back on the beach, and eventually drove home. That's essentially what they did in this experiment. But what they found was these neurons that release epinephrine, there's another cell type called glia, which actually means glue in Latin, that is paying attention to how much epinephrine is being released. And at some point, the system reaches a threshold. It reaches this threshold and it shuts off the release of more epinephrine. It's like I quit, that's it, no more effort signal. If they could extend the time before those glia said, enough, if they could release more adrenaline into the system, then subjects would keep going. So our desire to continue, or put differently, our willingness to continue and our desire to quit is mediated by events between our two ears. Now, that doesn't mean that the body's not involved, but it means that neurons are critically important. So we have two categories of neurons that are important: the ones in our head that tell us get up and go out and take that run, and the ones that allow us, encourage us to continue that run. And we have neurons that shut things off, that say no more. And we, of course, have the neurons that connect to our muscles and control our muscles. But the reason we quit is rarely because our body quits. Our mind quits. Now, I would never want to encourage people to drive themselves to the point of injury. That's not going to be good for anybody. But it is good to know that it's neural. Our ability to persist is neural. So when people say, I hear that, sports or effort or fighting or it's 90% mental, 10% physical. That whole discussion about how much is mental, how much is physical is absolutely silly. It just proves that there's no knowledge of the underlying biology behind that statement. It's neither mental nor physical. Everything is physical. Everything is neurons. Your thinking is the responsibility of chemicals and electrical signals in your head. So it's not 90% mental, 10% physical. It's not 50-50. It's not 70-30. It's 100% nervous system. It's neurons. Okay? So when people say mental or physical, understand it's 100% neural. And I'd love for how much of it is mental and how much is physical to just disappear. That argument means nothing and it's not actionable.